All right, so this is from our lesson 2.4 about linear regressions. So just to recap, linear regression just means the process of finding the line of best fit. Okay, so if it's asking you to find the line of best fit, we do a regression in Desmos. All right, so step one. I'm not even going to read all of this. I'm just going to do the problem and answer the question. So we have a table. We're going to go ahead and put in the table in Desmos. So to put a table in Desmos, to put your X and Y, you're going to press the plus button and then table, and then we're going to go ahead and plug in our values. These are the X values right here. So 0, 4, 8, 12, 16, and 20. And then the Y values, just plug all of them in. So just make sure that when you are plugging them in, you are matching up the X and Y value to whatever it says. Okay, we can't just mix them all up. Okay, a couple more. 1921, and then 2038. Okay, once I have plugged in, obviously I'm not going to be able to see them on here because the numbers are so big. But if I zoom out, you should see them eventually, and there they are. You notice they are kind of going in a linear pattern, okay, and it does look like it's increasing. So I'm going to expect my correlation coefficient to be at a positive number. Okay, so enter the data into the graphing calculator and determine the linear regression model. So some vocabulary here. Whenever it asks you for a model, a regression model, it just means it's asking you for the equation, okay? So this is the same thing as what is the equation, okay? And we know how to do the equation. We just make sure we write it in y equals mx plus b form, okay? So the slope and the y-intercept. All right, so to do the regression, we're gonna type the regression model. Okay, I just discovered something. Instead of typing the regression model, y1 regressed against mx1 plus b, I think Desmos actually made it a little better. Okay, so rewind. You're going to go here and you're going to click on this scatter plot, add regression. And since we're doing it, oh, there it is. So this is definitely a linear regression, but the options give you regressions for a lot more other ones. But we're just going to keep it a linear regression. And here is my equation. We're going to go ahead and write the equation down. So you have y equals 41.37. I'll just do 2 decimal places. X plus 1244.95. So my slope here is 4137, and then 1244.95 is my y-intercept. All right, what is the correlation coefficient and what does it mean? So the correlation coefficient is right here. R equals, the lowercase r right here, equals 0.9956. It means that it is a strong, because it's 99%. Actually, it's almost 100%. Strong. And it is positive because it's a positive number, and it's because it's going up. Strong, positive, linear fit. Okay, so this equation fits this data really, really good. All right, using the regression model, remember the word model just means the equation. So I can read this as using the equation, use the equation to predict the number of bachelor's degrees that will be granted in 2035. Okay, so this is the year 2035. 35. Okay, this will be a little tricky. Let me go back up here to see what that number is going to be. So notice that here it says number of years since 2000. So 0 plus 2000. So this is actually the year 2000. 4 plus 2000. So this is actually the year 2004. And this is 2008. This is year 2012, and then so on, 2016, and then 2020. So we are actually looking for the year 2035. So 2035. So my x value is actually going to be 35. Okay, so the x value that I'm going to use is going to be 35. So we're trying to find the y value for it. All right, so here is the equation. So what I'm going to do here is I don't know if it'll let me copy it. Hold on, what is this? Do export a snapshot? Oh, look at that. You guys, I'm literally discovering this with you right now, okay? I'm so excited about this because last year we had to like type all of these numbers in. Where am I? Let me show you where I am. We had to actually type all of, hi, I'm here. We had to type all of these numbers in, okay? And it was really, really difficult to try to remember how to type the regression and all those things. So I'm happy. Yeah, just wanted to see me smile. All right, I'm turn off my camera now. Anyway, so what did I do? I just pressed this here, it copies it down. Now, what is this? Why did I copy it down? Because I need to use the regression, so use the equation to predict for the year of 2035. So so basically when x is equal to 35, what is my y value? Okay, so what I'm going to do here is watch closely what I'm doing. So I'm going to put a parentheses around the x, and I'm going to remove the x and substitute the number 35 so I can see. So basically what Desmos did was take this, multiply it by that, and then add the y-intercept, and we get 2,692.95. So in thousands, I should probably round this up. So this is actually going to round up to be 2,693 degrees. Okay. All right. Use the regression models. Again, use the equation, which is right here, to predict when U.S. colleges and universities. So when it says the word when, that means that I'm looking for the year. Will grant $5,000. So I'm going to go back a little bit, and then I'm going to bring down the equation again and show you that if I'm looking for the year, that means that I have to change the y coordinate now. I'm plugging in y, so I'm going to put parentheses around y and take off the y, and then I'm going to put the 5,000. So I'm going to go ahead and put 5,000. Okay, so now this one, it didn't give me a number here, right? It didn't give me a number. Actually, let me go back a little bit. Let me start over. So if I go back, so you can see it all together. So we know how to find, when we're given x, I found the y right here. Now what about when we're given, let me do the next one here. So when we're given y, so I'm given y as 5,000, it doesn't just nicely give me the x coordinate here, right? So for this one, it's a little bit more tricky. It's basically right here. Let me see if I can make this. So if I just click on the blue line anywhere, okay, my x is at 90 right there. So 90.7. So actually I can round that up to 91. You see it? It's right there, 91. Okay, that my x value. Okay, I don't have two mouses that I can show you, but it's right there. So it's going to be, so when x is equal to 90, I'll round that up to 91. my y is at 5,000. You can test it if you want. Like, for example, if I want to get another equation, and then I want to test if it's 91, actually. Let me see. So if it's 91, that's about 5,000. It's not going to be exact because I have all of these other numbers in there. So anyway, that works. So there you go, you guys. That's what we have. Actually, hold on. 91 is not the answer. The year is actually going to be what? 2091. Okay, so that's the actual answer. All right, let me go to the next page. Okay. All right, so the next example, let me go ahead and take all this off. So I see a table, I'm plugging it in. Here's the table. All right, so it says here, the following table contains the average tuition and fees paid for all four-year public college. Okay, so from 1990 to 2015. Okay, enter the data and enter the data into the calculator and determine the linear model. Let x be the number of years since 1990. Okay, so I'm gonna go ahead and use the x, put a x here since 1990. So if it's since 1990, I'll just put it right here. So 0 plus 1990 is 1990. What plus 1990 gives you 1995? So it's 5 years, right? And then for 2000, it's going to be, so basically 2000 minus 1990 is 10 years. Okay, because look, if I do 1990 plus 0 gives me 1990. 1990 plus 5 gives me 1995, plus 10 gives me 2000. I'm guessing it's plus 15. Yep. So the x value here, because I need to put these values into x. I cannot just put the actual years because the data will be a little messed up. Maybe it'll work, I don't know, but I'm just going to do it this way. 1990 plus 20 should give me 2010. Yep. 1990 plus 25 should give me 2012. Okay. All right, so that's that. Let me go ahead and plug in the data into the table. So you have 0, 5, 15, 20. And then here I have 1990, 1905, 2000. Wait, that's not what I... Oh yeah, no, that was right. No, it was not right at all. Let me start over. Whew, 0, 5, 10. Okay, and the numbers for my y value are this. So my y value is right here. So this column. That's what I was wrong. Okay, another thing with Desmos, do not put commas, okay? Just put the numbers, do not put comma, because if you put comma or even the dollar sign, it's gonna give you an error message, okay? $12, $6.25. Okay, I'm going to press the home button, and then obviously the numbers are really, really way up there, right? Like super, super up there right there. So when I look at this, it's really hard for me to tell if it's linear perfectly or not. But anyway, that's what it is. So let's go ahead and do the regression. So to do the regression, we're going to press this, add regression. It's a linear regression, and here's my equation. So you have y equals 446.29 right here, x plus 5,265.43 y. Okay. What is the slope? So the slope is the coefficient of x. So that's 446.29. And then it means that for every year, the cost of tuition goes up. Here, let me type it all up for you. Every year, the cost of, oh, that's big, tuition. Why is my, okay. The cost of tuition goes up by $446.29. Every year, the price increases by that, okay? All right, use a regression model to predict the cost of a four-year institution in 2028. All right, guys, so 2028, it is, so 2028 is like right here, right? So this is 2028, it's somewhere over here. So I don't know how many years that is for, oh, 18 years after 1990. Okay, well, I'll tell you right here. Well, let me show you how I got that number. So I can do 2028 minus, since my starting year was at 1990. It's 38 years. Oh, 2008, my bad. Yeah, 18 years, okay? So 18 years, so that means that when my x is at 18, find what y is equal to. So to do that, I'm going to go ahead and click that, which copies the equation down. So I'm going to do 18, plug in 18. I have to remove the x to be able to calculate. So in 2008, the cost of tuition would be $13,298.57. Okay? All right, use a regression to predict the cost. That will be at 30. So for it to be 30, what I'm going to do is I'll go ahead and copy the equation again. And then I'm going to change the y in this case. So the y is going to be at 30,000. Remember, no commas in Desmos unless you're making what do you call it? Putting in a coordinate. Okay, so I'm going to zoom in. I know it's the blue graph right here. So it's going to be at 55 years after. Okay, so 55 years after. What is it? Was the starting year 1990. So that means that 1990 plus about 55 years, so the year is going to be the year 2045. Okay, so that's my actual year. It says use a regression to predict when, then the when would be like at what year? So at year 2045. Okay, and so this was the answer for my y, and then that was the slope and what the slope means, and then this is the actual equation. Okay, all right, I think I have one more problem on this. All right, so let me go ahead and put this in here. I'll do it really quickly this time. Okay, so I plugged it in. I'll go ahead and do a model right here, linear model, copy this down. I'll do 6, 8. Okay, and I have 6, 7 here, but you have a 5, and then that rounds it up to 8. Thank God it rounded up to 8 and doesn't stay at 6, 7. X plus 25.4. I'll just round it up to 3. Okay. All right, so I have it here. What is the initial value? So remember, the initial value is the y value right there. So the initial value is 2543. And what does this mean? So the initial value tells you that when the water depth or the temperature was initially, here, let me type it up. Like, what is Miss Nicola talking about? Okay, so when the water depth, which is the x value, was at 0. So basically when your x is at 0, so 0 meters, the temperature, the y value, was at 25.43, or I should just say 4 Celsius. Okay, that's what that means. That's what the initial value means. Okay, all right, the next one says, predict what water depth had a temperature of 15. So now notice that the temperature is the y value. Okay, so we have to be very careful here. So the water depth is your x value, and then your temperature is your y value. So the temperature is at 15. Because that's important, because when we're using the equation, I have to know what to plug in for. Okay, so I'm going to plug in the y to be at 15, which means that my x value is at 154.28. So the x value is at 154.28. Okay, so that's my water depth. Okay. All right, Susan would like to estimate the temperature at a depth of 180 meters. So again, the depth is 180 meters, which is your x. And then Fatima would like to estimate the temperature at a depth of, so I have 2 here, okay? 2 x's, 5,000. Which estimate is more valid and why? Okay, so let me see here. So the first x that I have here is that, so Fatima, Susanna is at 180. And then y, and then let me do another equation. What is it? Fatima is at 5,000. I'm going to take off, make sure to take off the x. Okay, so it looks like, so for 180, my temperature is at 13 degrees. And then the other, for at 5,000, the temperature is at 312. Okay, so which estimate is more valid would be the first one, Susanna's, because having temperatures go this low doesn't, I don't think really happens on this earth. We can't sustain that low of temperatures. So I would say Susanna's is more valid. Okay. Because this one is too cold. Too cold. All right. Thanks, guys. That's the end of Unit 2.